So welcome to the video lecture series on finite languages in automata theory. In today's lecture, we will be learning about finite automata to regular expression. That too we are going to do with Arden method or Arden theorem. So in this diagram, you can see there are three states spanning from A1 to A3. So as far as Arden method or Arden theorem is concerned, we have to compute the incoming edges for each state here. So we will compute the incoming edges for state number A1. So A1 A1 so A1 you have an edge from A1 itself, A1 0 thus, and you have an edge for from A3. So A3 0, and that's it. Only two edges are there, but since this A1 is actually an initial state, we will make epsilon here. So this we name it as equation number 1. Now we will go for the second equation, second state here. The second state is A2. So A2 is having A2 is equal to A2 is having an incoming edge from A1. So we will write A11 plus A2 is having an edge from A2 itself. So A21, and A2 is also having an edge from A3, isn't it? So plus A31. So we will name this equation as equation number 2. Okay. Now we will go for the third step, equation number 3, that is A3 here. So A3 is equal to, so A3 is having an edge from, incoming edge from A2. So we will make it as A2 0. So that's all, only one incoming edge from for A3. So we'll name this equation as equation number 3. Now, what is the final state here? The final state is actually in this diagram, we call it as A2 is called as a final state. So we'll make it as A2 is a final state. Okay. So it will be mentioned as final state here. Now to compute A2, what you require A1 and you require A3. So you have to compute both the states here. Now what we have to do is the most simple equation is called as A3 is equal to A2 0. Now we will apply this equation number 3 in equation number 1. Okay. So we will try to apply equation number 3 in equation number 1. So apply equation number 3 in equation number 1. So when we try to apply, what happens is this A1 can be written as A1 0 plus, so instead of this A3 you apply A2 0. Okay. So A3 is replaced by A2 0, and already 1 0 is there. So make it as 0, and then 1 epsilon is added. Now see here, where we can take this equation in a form. For example, we apply this equation to the standard form. So standard form is, this is called as R, and again this is called as R, this is called as P, and this remaining part, whatever which is remaining here from A2 0 0 to epsilon, everything is called as Q here. Now we will just reduce this to a standard format. So that means R can be rewritten as R is equal to QP star. So R is equal to, now Q is A2 0 0 plus epsilon, and then we will apply P. P is actually 0, so 0 star. So this is equation, this equation R is actually, R can be written as, is actually A1, okay, it is A1, R is actually A1 here. So this equation, we name this equation as equation number 4, equation number 4. Now we know the value of A1, isn't it? Now we'll take this A1 value and apply it in A2 here, okay. We'll take this A1 value and apply it in A2. Now, how will you apply this? So, to apply this, very simply you can do this. Now, see here, what is the equation of A2 here? A2 is A1, 1, okay, and A3 we have already know what is the value. So, not what we have what we have to do now is we have to apply equation number 4 and equation number 3 in equation number 2, okay. So, apply equation number 4. Equation number 4 is the present equation which is given for A1, and equation number 3 and equation number 3 in equation number 2. That means we are applying equation number 4, 3 in equation number 2. So what is equation number 2? It is written as A2 is equal to A1 1, A2 1 plus A3 1. Okay. So we will just take this equation A2 here. So A2 is equal to A1 1, this is equation number 2, and A2 1 plus A3 1. Okay, this is equation number 2. Okay. Now what we will do is we will actually apply the respective values here. So we will substitute A1 value here. A1 value is A2 0 0 plus epsilon 0 star. Okay, we'll substitute this value. So A2 is equal to, instead of this A1, replace it by the corresponding value. So A2 0 0 plus epsilon, then we have 0 star, and A1 1, isn't it? So already 1 is there here, plus A2 plus 1, A2 1, and now you apply A3 1 is there, okay. So instead of A3 you apply equation number 3 here. What is equation number 3? So equation number 3 is A3 equal to A2 0, okay. So this A3 can be substituted as A2 0, and already 1 is there, isn't it? So now this is the equation which we have got here, okay. What we will do is we will abbreviate this, okay. So this 0 star 1 is a common term for A2 0 0 plus epsilon. So we will multiply this. When you multiply this, simplify this, this will be A2 0 0 0 star 1 plus, now this, when you multiply with epsilon you will get the same value, 0 star 1 plus A2 1 plus A2 0 1. Now we can see here that we can take A2 as a common term here. So when you take A2 as a common term, 0 0 0 star 1 plus A2 1, 1 is there, and 0 1 is there. So we'll take this out. We'll take this A2 out. A2 out means then this will be written as 0 0 0 star 1 plus, and this one plus 1, and A2, when you take this A2 out, what will be remaining? 0 1 will be remaining. And what is already remaining here? this portion 0 star 1 is already remained 0 star 1 is equal to A2 here. Now you just compare with the standard form here. So what is the standard form? This is considered as R, this is considered as again R, and this entire portion is considered as P, and this portion is considered as Q here. Okay, we will reduce it. So how to reduce it? So we can reduce it as R is equal to QP star, isn't it? So what is R here? So A2 is R. Then what is Q here? It is 0 star 1 is Q. And what is P here? P, this entire portion is called as P. So 0, 0, 0 star 1 plus 1 plus 0, 1 to the power of whole star. So this is the final equation for the final state called as A2 is equal to A2, state A2. So thanks for watching the video. Have a good day.